All right, so this is just follow up on today's inferential statistics lecture here in the corner. And I know we went fast, so I decided to shoot this video for you. Just a reminder, inferential statistics, we are just trying to now make hypotheses and understand something relative to the population. And we've done this with confidence intervals, but we didn't calculate a p-value. So that's really what we're doing. And for every inferential test, there is a null and alternative hypothesis required and a test statistic. So remember, we collected, organized, summarized, and presented data. We did that with means and frequency analysis, other measures of central tendency like a median and mode, other measures of dispersion like a standard deviation variance. Now we're going to make inferences. Now we're going to test some hypotheses. Now we're going to determine relationship, and we may even get to regression, which allows us to make predictions. So, as I've already said, alternative, null, we need those. We need a reject region, which is p less than 0.05, and obviously our test statistic I'll talk to you about in a minute. So I mentioned the one sample z-test. It is a univariate test, and when I say univariate, all I'm talking about directly from your text here, as you see here, is that it has one dependent variable. Multivariate tests have multiple dependent variables, but in this case, the t-test and z-test have one sample, right? But then we have only one dependent variable, or the variable that fluctuates, okay? The null and hypotheses that we need to focus on are, one, that the population mean equals the hypothesized mean, okay? That's really what we want, right? We want that our data from our sample matches the population. Thus, alternative hypothesis might be that it's different, greater, or less than, and for two-tailed test, it's this first one. The population mean differs from the hypothesized mean. So remember, we're just comparing it to a target or reference value. So we're comparing the population mean, which we don't know, to the mean from our sample. Then we have the t-test, which is the exact same test, okay? Except for, we use this one when the standard deviation of the population is not known, and so you'll never actually calculate a z-test in this course because we'll never actually know what the population standard deviation is. We will use a t-test, and here's an example. In SPSS here, I've got our Pandora data up, right? So I'm just sitting here looking at, you know, the overall satisfaction switch for a song selection and so on. So earlier, what we did is we went to analyze descriptives, and we calculated that descriptive statistic for overall satisfaction, right? It was a mean and a standard deviation. When I calculated that statistic, what it gives me is I have overall of satisfaction of 3.24 and 1.43. Is that meaningful? And specifically, is that meaningfully the same as what I would see in the population, or is it not? And remember, in this case, our goal is for them to be the same, so we will want to fail to reject the null. Going back to the slides here, for a one sample t-test, the hypotheses are the same for a one sample z-test and a one sample t-test. And we want them to be equal because we know that we're speaking about the population. If they're different, then we know that what we've found is not the same as what exists in the population. So real quickly, again, you'll never run this in class, but to run it, you go to analyze, you go to compare means, Then you'd hit one sample t-test. When you open that up, you take set music service and you put it in. And then in our options, it would already tell us that we're going to have a 95% confidence interval, which is equivalent to a p-value of 0.05. Then we'd hit OK. And here it is. Basically what it's telling us is that here's the mean and the standard deviation and standard error. And for this significant test, it is significant. So what this mean is different, right? It's p less than 0.05. It is different. Here's the alternative. The population mean differs from the alternative or from the hypothesized mean. So the population mean differs from our mean is what this hypothesized mean is. And the null is the population mean equals a hypothesis mean. Well, when p is less than 0.05, we have to fail to reject we have to reject the null, right? We have to reject the null. And in this case, we have to reject that the population mean equals the mean that we found. And in essence, that's what this test shows. So that would be the answer to the question. When I'm talking about the t statistic, this is the statistic for which this level of significance matters. Okay? All right. Next we have, so remember, you won't do a one sample, you won't ever calculate a z-test because we won't know the standard deviation. But you will calculate the t-test, which I just did. And it also calculated the range of values that is likely to include the population mean. Remember, I actually went in when I calculated that test, and it gave me something that you'll see is very familiar. It gave me the confidence interval. So this is just yet another way for you to calculate the confidence interval, 2.70 and 3.79. And this is a 95% confidence interval.